According to the National Electrical Code, all circuits must have a disconnecting means within sight of the equipment it supplies and must be of sufficient capacity to open the circuit under abnormal conditions. This is detailed in NEC 430.102b and NEC 110.26. In the situation described, both the 120 volts alternating current and 24 volts direct current power sources must be disconnectable from one location. This requirement stems from the fact that they supply power to the same equipment, which is the flashing light and the regular light. This falls under the purview of NEC 430.102b, which emphasizes the need for a single, accessible disconnecting means for equipment powered by multiple sources. Utilizing a relay for the flashing light is an acceptable solution, provided that the relay is appropriately rated for the 120 volts alternating current power source and its contacts are adequately rated for the 24 volts direct current load. Furthermore, the relay must have a disconnecting means that is accessible without needing to remove the relay from its enclosure, a stipulation outlined in NEC 430.72c. The presence of a yellow wire in a control panel typically indicates that the power is being supplied from an external source. However, it's important to note that this isn't always a definitive indicator. The NEC does not specifically mandate a particular color for wires supplying power from external sources. The yellow wire is most likely receiving its power from the main disconnect of the machine, since it's providing power to a component within that machine. The main disconnect must be designed to disconnect all power sources to the machine, and this includes both the 120 volts alternating current and the 24 volts direct current power sources. To summarize, it is indeed correct to disconnect both the 120 volts and the 24 volts direct current power sources from a single location. Employing a relay for the flashing light is permissible, contingent upon meeting the code requirements previously mentioned. The yellow wire found in the control panel is likely receiving its power from the machine's main disconnect. The NEC provides a comprehensive framework for ensuring electrical safety in various applications. It is essential to consult the latest edition of the NEC for the most up-to-date requirements and interpretations. Now let's go deeper into disconnecting means, NEC sections 430.102b and 110.26. These sections emphasize the importance of having a readily accessible and appropriately rated disconnecting means for electrical equipment. A disconnecting means is a device or group of devices that can disconnect an electrical circuit from its source of power. This is a critical safety feature that allows workers to safely perform maintenance or repairs on electrical equipment. NEC section 430.102b specifically addresses disconnecting means for motor circuits. It requires that a disconnecting means be located within sight from the motor controller location and the motor location. The disconnecting means must be capable of disconnecting the motor and all associated control equipment from all sources of power. This ensures that the motor can be completely de-energized for safe maintenance or repair. NEC section 110.26 focuses on providing adequate working space around electrical equipment. This working space must be clear and unobstructed, allowing workers to safely access and operate the equipment. The working space must also provide enough room for workers to perform maintenance and repairs without being exposed to electrical hazards. The requirements for working space vary depending on the voltage of the equipment and the type of work being performed. In the context of disconnecting multiple power sources, the disconnecting means must be located within the required working space. This ensures that workers can easily access and operate the disconnecting means in a safe manner. Now consider the use of relays and NEC section 430.72c. A relay is an electromechanical switch that can be used to control a circuit with a low power signal. Relays are commonly used in control systems to isolate different parts of the circuit or to switch between different power sources. NEC section 430.72c provides requirements for the use of relays in motor control circuits. It states that relays must be rated for the voltage and current of the circuit they are controlling. The relay contacts must also be rated for the type of load they are switching, such as inductive or resistive loads. In the case of the flashing light circuit, A relay can be used to switch the 24 volts direct current power to the light. The relay must be rated for 120 volts alternating current to be controlled by the switch, and its contacts must be rated for 24 volts direct current to switch the light. The relay must also have a disconnecting means that is accessible without removing the relay from its enclosure. This allows workers to safely de-energize the relay for maintenance or replacement. Next is yellow wire identification. While the NEC doesn't mandate specific colors for specific functions, use of yellow wire to indicate an external power source is a common industry practice. However, it is not a code requirement. The NEC does require that all conductors be identified by color coding or other means, but it does not specify which colors must be used for which applications. The purpose of color coding is to help workers quickly identify the function of a conductor. For example, green wires are typically used for grounding conductors, while white or gray wires are typically used for neutral conductors. The specific color coding scheme used in a particular installation should be documented and readily available to workers. In the case of the yellow wire, it is important to verify the source of power for the wire before working on the circuit. This can be done by tracing the wire back to its source or by using a voltage tester to check the voltage in the wire. Always follow safe electrical work practices when working on any electrical circuit, regardless of the color coding of the conductors. In summary, here's a breakdown. Firstly, disconnecting means are required by the NEC for all circuits and must be located within sight of the equipment they supply. Secondly, when multiple power sources supply the same equipment, all sources must be disconnectable from one location. Thirdly, relays can be used to control circuits with different voltage levels, but they must be properly rated and have a disconnecting means. Fourthly, while yellow wire often indicates an external power source, it is not a NEC requirement, and the actual source must be verified. Fifthly, the main disconnect must be capable of disconnecting all power sources to the machine. Some additional considerations: the specific requirements for disconnecting means, relays, and wire identification may vary depending on the specific application and the local electrical codes. It is always important to consult the latest edition of the NEC and any applicable local codes before working on any electrical installation. Furthermore, it is crucial to follow safe electrical work practices at all times to prevent electrical shock and other hazards. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using insulated tools. If you are not comfortable working on electrical equipment, it is best to hire a qualified electrician to perform the work. Remember, electrical work can be dangerous if not done properly. Always prioritize safety and follow all applicable codes and regulations. Considering the scenario of a flashing light and a regular light powered by different sources, the primary concern is ensuring the safety of personnel who may need to work on the equipment. The NEC provides guidelines to minimize the risk of electrical shock or other hazards. The requirement for a disconnecting means within sight of the equipment is intended to allow a worker to visually verify that the power is disconnected before beginning work. This is particularly important when multiple power sources are involved, as the worker needs to be able to disconnect all sources to ensure complete energization. The use of a relay to control the flashing light introduces another level of complexity. While relays can be a convenient way to switch circuits, they also add a potential point of failure. It is important to select a relay that is appropriately rated for the voltage and current of the circuit it is controlling, and to ensure that the relay is properly installed and maintained. The presence of a yellow wire raises a question about the source of power for that wire. While yellow is often used to indicate an external power source, it is not a guarantee. It is essential to trace the wire back to its source to verify its origin and voltage. In this case, it is likely that the yellow wire is connected to the main disconnect of the machine, but this should be confirmed. The main disconnect must be capable of disconnecting all power sources to the machine, including the 120 volts alternating current and 24 volts direct current sources. This ensures that the entire machine can be de-energized for safe maintenance or repair. In conclusion, the situation involving the flashing light and regular light requires careful attention to detail and adherence to the NEC. The disconnecting means must be properly located and rated, the relay must be appropriately selected and installed, and the source of power for the yellow wire must be verified. By following these guidelines, the risk of electrical hazards can be minimized and the safety of personnel can be ensured. Let's talk about some of the potential problems that can occur if these requirements are not met. If a disconnecting means is not readily accessible, it may be difficult for a worker to quickly de-energize the equipment in an emergency situation. This could lead to serious injury or even death. If a relay is not properly rated, it may fail and cause a fire or electrical shock. If the source of power for a wire is not properly identified, a worker may inadvertently contact a live wire and receive an electrical shock. Therefore, it is essential to take these requirements seriously and to ensure that all electrical work is performed in accordance with the NEC and other applicable codes and regulations. Electrical safety is a shared responsibility, and everyone who works with electrical equipment should be aware of the potential hazards and take steps to mitigate them. This includes following safe work practices, wearing appropriate personal protective equipment, and reporting any unsafe conditions to a supervisor. By working together, we can create a safe and productive work environment for everyone. The requirement for a disconnecting means to be within sight of the equipment it serves as a critical safety measure. This ensures that the person disconnecting the power can visually confirm that the correct equipment is being de-energized. It also prevents someone from inadvertently re-energizing the equipment while someone else is working on it. The definition of within sight can vary depending on the specific application and the local codes. However, it generally means that the disconnecting means must be visible from the equipment without any obstructions. In some cases, a disconnecting means may be located behind a door or around a corner, but it must still be readily accessible and clearly labeled. The NEC also allows for the use of remotely operated disconnecting means, but these must be clearly identified and must have a means of preventing accidental re-energization. In the case of the flashing light and regular light, the disconnecting means for both power sources should be located within sight of the lights. This would allow a worker to visually verify that both lights are de-energized before beginning any work. If the lights are located in a difficult-to-access area, such as high up on a wall or ceiling, it may be necessary to install a remotely operated disconnecting means. The use of a relay to control the flashing light introduces the possibility of a sneak circuit. A sneak circuit is an unintended path for current to flow, which can cause unexpected behavior or even damage to equipment. In the case of the flashing light, a sneak circuit could occur if the relay is not properly wired or if there is a fault in the wiring. For example, if the relay contacts are wired in such a way that current can flow through the light even when the relay is de-energized, the light may continue to flash even when it is supposed to be off. To prevent sneak circuits, it is important to carefully design and install the relay circuit and to thoroughly test it after installation. It is also important to use high-quality components and to follow all applicable codes and regulations. If a sneak circuit is suspected, it should be investigated and corrected immediately. Let's explore the implications of using a yellow wire to indicate an external power source. While the NEC does not specifically require the use of yellow wire for this purpose, it is a common industry practice. The advantage of using yellow wire is that it provides a visual cue to workers that the wire is connected to an external power source, which may be located in a different panel or even a different building. This can help to prevent accidental contact with live wires and to ensure that all power sources are de-energized before working on equipment. However, it is important to note that the use of yellow wire is not a substitute for proper identification and labeling. All wires should be clearly labeled with their voltage and function regardless of their color. It is also important to verify the source of power for any wire before working on it, even if it is yellow. In some cases, a yellow wire may be used for a different purpose, such as a control signal or a communication wire. Therefore, it is essential to trace the wire back to its source and to verify its voltage and function before making any connections. The main disconnect plays a critical role in ensuring the safety of electrical equipment. The main disconnect is the primary means of disconnecting all power sources to the equipment. It must be capable of interrupting the maximum fault current that could occur at the equipment. The main disconnect must be readily accessible and clearly labeled. It should be located in a convenient location, such as near the entrance to the equipment room or near the equipment itself. The main disconnect must be capable of being locked in the open position to prevent accidental re-energization. This is particularly important when maintenance or repair work is being performed on the equipment. The main disconnect should be inspected regularly to ensure that it is in good working condition. Any damaged or worn component should be replaced immediately. The main disconnect should be tested periodically to verify that it is capable of interrupting the maximum fault current. In the case of the flashing light and regular light, the main disconnect must be capable of disconnecting both the 120 volts alternating current and 24 volts direct current power sources. This may require the installation of separate disconnects for each power source, or the use of a single disconnect that is rated for both voltages.